Proving identities. An identity is an equation that is true for all valid inputs. So that means the inputs that would be um, in the domain of both the left and the right expressions. So it's not like an equation. So like an equation would be in a conditional statement, something like this, where we say, okay, this is only true when I get, let's see, 2x equals -1, x equals -1/2. And we say, okay, so 2x plus 1 equals 0. That is only true when x equals -1/2. But here we're talking about identities. So just looking at this example we're going to get to, it's going to say prove this identity. This is saying this is true for every angle theta that is allowed in the domains, right, of these trigonometric functions. So proving an identity means showing step by step how to get from one expression to the other. So the rule is, like, we have to kind of follow the rules here. In order to prove an identity, we will need to choose one side and stick with it. And this will become more clear as you see some examples. The other side must remain untouched. So we choose one side, doesn't matter if it's left or right, it's up to us, and then we're going to stick with that side. Okay, so sometimes it can be helpful to start with the more complicated side. Okay, so the more complicated side, find a common denominator. Okay, we've done that. Write in terms of sine and cosine and factoring. And there's a couple other tools that'll help, they'll kind of show themselves along the way as we get into this. And so these examples are just asking us to prove each identity. Okay, so let's start with the identity. Sine of theta times the quantity, cotangent of theta plus tangent of theta equals secant of theta. So in the tips above, it suggested, right, that we start with the more complicated side. So this left side is certainly more complicated than just secant theta. There's not a lot to go on. So again, what I'm after is start with sine of theta all times cotan of theta plus tangent of theta. So I'm going to pick that side. So I'm going to start with that side, and I'm going to do some trigonometric algebraic moves on this expression one at a time, so it's very clear what steps I took. And then in the end, it should all equal secant theta. So it's kind of like these simplifying problems that we've worked on, where we are taking some big kind of nasty thing and trying to simplify it down and say, what are you equal to, right? Let's get you kind of spiffed up. But in this case, you could argue that it's easier because I know my goal is that this whole thing needs to equal secant theta. Okay, so you're kind of like peeking in the back of the book and going, that's the answer that I need to get for this. Okay, so without doing anything to secant theta, right, that means like I've kind of like, you can always, sometimes I think of it kind of as like locking it in like a little padlock, okay? Without touching that, I need to turn that left side that I've written here into secant theta. Okay, so the first thing I'm going to do here, when I look at this, it's not entirely clear of what to do. And that's part of this, right? The more you do, the better you'll get at them. But it's not like when I look at this, I don't just see the exact way I'm going to do every little step. But what I do see is that I don't have everything in terms of sine and cosine, and that can help me. So I'm going to write this as sine of theta times, and then I'm going to write cotan of theta as cosine of theta over sine theta. And then I'm going to write tangent of theta as sine of theta over cosine of theta. Okay, so notice how my next equal sign just goes right below the one above it, and there's nothing written on the left side. So the only thing written on the left side is that first starting expression that I've picked, right? I pick this, I write it here, and then nothing goes underneath that. Everything is going to go on the right-hand side, just line by line. So that's how I want you to write it out. Okay. So now from here, what I'll probably do is just multiply in the sine theta and see what we get. So when I do that, let's see, I get sine theta cosine theta over sine theta, okay, plus sine theta times sine theta all over cosine theta. Okay, well, these sine thetas are gonna, in this first term, are gonna cancel out to give me just cosine theta. Okay, that might be helpful. Plus, this is gonna give me sine squared theta over cosine theta. Okay, well, that helped a little bit maybe, but I still don't have just like a plain secant theta just staring at me. So anytime you have two terms and one of them is a quotient or a fraction, so I see I have sine squared theta over cosine theta, I am going to write I'm going to find a common denominator, add them together. So this one already has a denominator, right? So I'm going to leave it alone. But I am going to take my cosine theta that I already have, that's my first term, and just multiply it by cosine theta over cosine theta. Okay. So again, each time I'm not changing like this expression that I started with, this whole thing, sine theta times cotan theta plus tan theta. That thing I didn't change when I went from here to here. I just said I used the definition of cotan theta, right? That's that quotient identity. Same with tan, quotient identity here. Then here I just multiplied in, right? That's not changing anything. I'm just using my distributive property. Okay. Then I canceled out signs. That's allowed, right? Now I'm just finding a common denominator. Okay. So now I'm going to get, let's see, cosine squared theta plus sine squared theta, right? I can, now that their denominator is the same, I get cosine squared theta plus sine squared theta all over cosine theta. Now, why does this help me? Well, I think it helps me because now I have a Pythagorean identity in the top, so I can use that identity here. So I can rewrite the numerator as 1, and the denominator is still cosine theta. And 1 over cosine theta is secant of theta by my reciprocal identity. And then, aha, I did get to the end, right? I got it equal to secant theta just by following these mathematical, legal, allowed moves. So sometimes we like to end it with something fancy. We make a little therefore symbol, which is like a triangle made out of dots. So we say therefore, and we write that beginning expression. Let's go back to it. Sine of theta all times cotan of theta plus tan theta, right, equals secant of theta.